Now that we know how to tell whether or not an Euler path or circuit exists, the next natural question is, if one exists, can we find it? So I'll show you one approach to finding an Euler circuit in this case through a graph. One way that you can sort of systematically approach the problem rather than just guessing and looking for one. There's a way to break it down into smaller steps. This algorithm approach works pretty well, and it's fairly easy to use. So I'll take this example. It's a relatively complicated looking graph, so it gives us a sense of how something like this could work on one that you just can't spot the answer immediately or with one try. So the approach basically boils down to starting with a circuit, any circuit that doesn't reuse edges. So we'll start with a closed circuit, starting at any point that doesn't reuse the edges on it. So just for example here, let's say I start at A, I'm going to come back to A, but I'm going to go from A, then to B, then to D, then to F, then to G, then back to D. Notice I can reuse vertices but not edges. And then from D, go to C, and then to E, and then to A. And this circuit, this initial circuit, can be as long or as short as you want. I could have just gone from A to B to E, and then back to A. But the longer circuit you kind of start with, the fewer steps you have to take. If you take really small circuits at a time, it takes you longer to get there. So by taking a relatively long one, I can do this in just a few steps. So the significant part was that it is a circuit, so started at A, and then back to A, and that it was a simple circuit that didn't reuse any edges. So it's a closed, simple circuit. Then once I have that, what you do is you delete those edges you've already covered. So basically you remove the part that you've already found a circuit through and focus on what's left over. So if we delete those, deleting those edges and then any points that are left isolated. So if you start deleting those edges, you'll find out that C and D and B and A are isolated, and so you remove those as well. So you're cutting away anything that you've already covered. And this is what's left behind. So you've got that new, smaller graph, the subgraph of the original, where we can focus now on this more restricted area. And then all you do is just repeat this process. So now we're going to repeat the process. So for this one, we're going to start at E and come back to it. So we'll just do a simple version, go to F, then to I, then back to E. And again, we could take more steps to do this, but all you need is some closed circuit that comes back to, some simple circuit that comes back to E. So once we have that, we repeat, we delete those edges, and what's left is just the sort of right-hand side there. And then we're going to repeat again. So for this one, I'll go from I, I'll do something like this, out to J, and then down to H, G. And again, I could do this in several steps, but we can come back like that. So there should be an H in there. After K, it goes to H and then to I. So now that we've done that, we've covered all of the edges in the original graph just in segments. So we've got 3 stages where we've deleted sections as needed. And then all you do is you look at those 3 circuits that we have and kind of stitch them together. So to do this, what you do is you kind of work backwards. And you think about this whole circuit here started and ended at I. And then going back one step, there's a stage in that previous step where we pass through I. And so you basically replace the stop at I. Instead of stopping at I and then going immediately back to E, you sort of pause and do this circuit to cover the whole remainder there on the right, and then you pick up and go back to E. So you kind of stitch it back together by replacing the I with this expanded circuit that starts and ends at I. So it still keeps a circuit, it still keeps a simple circuit, but it includes more of the graph together. And then once you have that, now you say, I have a longer circuit that starts and ends at E. So go back to the previous one and find when we pass through E and do the same thing. Replace that E with this long string that represents the remaining circuit. And so by doing this, you can kind of stitch it together to end up with a long final string. And so I'll show you the result of doing that. You replace I in the second circuit with the whole last example, so it looks like that. Or instead of E, F, I, E, it's E, F, then the entire last example. So it should be an H in there. And then coming back to E. And then you take that string and you insert that into the first one. So you get this long final string. And I won't bother drawing that out for you, but you can go back and retrace that on the original graph and see how it's an Euler circuit. So that's kind of one approach, just taking a simple circuit that covers part of the graph and then deleting that and repeat that until you get the full coverage, and then just kind of stitch it back together from the end back to the beginning.